and students, welcome to the video lecture. It's basically a practical session for digital technical microprocessor course. Previously we have already covered experiment number 1 to 5. Now we'll move to the experiment number 6. So this is experiment number 6, which is nothing but implement combinational circuit using multiplexer. So we need to perform 1-bit binary addition and 1-bit binary subtraction in the digital circuit, half adder and half subtractor. As we have already studied this in theory, so we will implement it, and we will implement the same with the help of multiplexer. So let's go to the circuit diagram. So this is the circuit diagram, this is the block diagram or symbol of half adder, then this is the realization using gates, and this is the truth table. Now let's verify this. So I have created this. So what I can do, I can create the same circuit with the help of what we can say our Tinkercad. So let's go to the Tinkercad. So what I'll do, I'll create a new circuit. This I'm going to rename it, that is half adder, and then I'm going to take a breadboard. So I'll take a breadboard. Now we can take a small breadboard also, because that will be sufficient, I guess. Okay, if you want bigger breadboard, that also you can take, not an issue. So I'm going to take this smaller breadboard. I'm going to zoom it so that it will be more visible to all. After that I need a power supply, so I'll search for power, and I'll take this power supply, and this will connect over here. Okay, this positive will connect to this, and I'll make the color as red. This negative will connect to this, and I'll make the color as black. Again we can connect this positive to positive and negative to negative, so that the bottom and top side will be shorted. Okay, and current will flow from this positive to positive side and negative to negative side. Next, what we want to implement, we want to implement half adder. Okay, I hope this is visible to all of you. In this we have two inputs, A and B. So let's take two switches to get A and B. So I'm going to take this light switch. Okay, this is, let us say this is A. Next we'll take another slide switch. Let us say this is, okay. Now I'll connect this first terminal to ground to make it and I'll make it black, and another terminal to red, that is VCC. Similarly I'll do this for second slide switch, make it black, this last terminal to red, so that whenever this switch is on this side, this will be connected to ground, and whenever this will be on this side, it will be connected to red. By default it will be connected to ground. Now, so this is A, this is B. What I want a XOR gate, so I can search for XOR gate. If you remember the IC number, that will be much better. But if you don't remember the IC number, then you need to search. So either you can search like this, okay, or what you can do, you can type over here XOR gate IC number, like this, and that will give you the IC number, that is 7486. Now you can type over here 7486, and this is called XOR. Okay, that you can take over here. Okay, like this. If you observe, this is power pin, so I can connect this to VCC. Okay, now if you observe, this is the benefit. Since we have already shorted this to this, I can directly connect this to this. If I have not done this, then I should have taken this wire to this side. That makes this circuit more complex. So that's why this type of connection needs to be done. This is ground pin, pin number 7, so that will connect to ground. I'll make it black. Now what I want to do, I want to connect A to X input, B to input. So this A input I will connect to pin number 1, okay, and this B input, that also I will connect to pin number 2. I'll make the colors a bit different. So green is for A and orange is for B, and the output will be available at pin number 3. So what I will do, I will get it and I'll connect it over here. So, and I'll change the color. So this is A XOR B, and I'll connect a register over here in order to see the status of sum. So I'll search for a register that I'll connect over here, or you can do over here, not an issue. In that case you have to connect this to this one. Keep it 1 kilo, not an issue. And then we need to connect a LED. The anode of LED is connected to register and cathode should be connected to ground. Okay, so I'll make it black. Now we can see the status of this sum at this LED. Now we need this carry. So for that we need AND gate. If you remember the AND gate IC, that is okay 74 I guess 08 is the IC called AND gate. If you don't remember, again you can search for the IC number and you can put it over here. This is power pin, so this will be connected to VCC. I'll make it red. This is ground pin, so I'll connect it to ground. This I'll make it black. Next, input should be connected. Okay, so A I need to connect to pin number 1. So what I can do, I can either connect from this point, or what I can do, I can connect, since already it is taken to this, I can connect from here to here also, not an issue. So any point you can take, not an issue. All of you got? So I'll since this is A, I'll make it green. Since this is B, I'll make it orange. So A is connected, B is connected. Input A, input B. Next, this is output pin, which needs to be connected to register. So I'll connect to this. I'll give another color, let us say purple. I need register over here. So what I can do, I can search for register. So I can take this register, I can connect over here. LED I'll take, I can connect it, and I can connect it to ground. So cathode is connected to ground and anode is connected to register. Registered second terminal is connected to output. So this will give me sum, this will give me carry. So I hope all of you understood this connection. Now let's see the simulation. So what I can do, I can take a copy of this print screen, okay, and I'll paste it over here for just for reference purpose. Okay, so this is the circuit which we created. Now let's verify this, whether we are going to get this or not. So the first combination is 0 0. So I'll apply 0 0. I'll start the simulation. So as soon as I start the simulation, input is 0 0, output is 0 0. So 0 0. So it is true. Next is input is 0 1. So A is 0, B is 1. As soon as A is 0, B is 1, sum is 1, carry is 0. Sum is 1, carry is 0. So hence true. Then A is 1, B is 0. A is 1, B is 0. So sum is 1, carry is 0. Sum is 1, carry is 0. Okay, sum is 1, carry is 0. Next is 1 1. So the last combination is 1 1. So 0 1, 0 1. Hence true. So I think all of you understood how half adder works with the help of logic gates. If you want, we can take a snapshot of this for our reference purpose. So we'll make it 0 0 and we'll take a snapshot of this and I'll paste it over here just for the reference purpose. So here A equals to 0 and B equals to 0. So for this is the thing. Okay. Next, A equals to 0, B equals to 1. This is the combination. So A equals to 0, B equals to 1. This is the status. So I can take a print screen of this. I can post it over here. Next combination is A equals to 1 and B equals to 0. Let's check out what is the status. A equals to 1, B equals to 0. So this is the status. You can paste it over here. Last combination is A equals to B equals to both are 1. That is the last combination. As soon as we make it, we'll give the status. We'll post it over here. So I hope all of you understood this. Now let's implement this half subtractor. Okay, we'll implement it in the same fashion. Okay, we'll implement it in same fashion. So I'll just save it. And what I can do, I can implement it of subtract. So I'll stop the simulation and I'll create another circuit. Now here I am going to take a bigger breadboard because I need it. I am going to need 3 ICs. I'll show you that. Okay, I'll give the name. This is half subtractor. Changed. Yes. Okay, now why I need 3 ICs, I'll show you. One is XOR, NOT gate and AND gate. So that's why I need 3 ICs, and since 3 ICs are required, I'm going to use bigger breadboard. Now this is a symbol of half subtractor. This is relation using gates. Let's verify this. So what I'm going to take, I have already taken a breadboard. Now I'll take power supply. Take this power supply and I will paste it over it. Here as usual we'll connect this positive to positive. I'll make it red, negative to ground, I'll make it black, and then this positive will be connected to this positive. I'll make it red, and this negative will be connected to this negative. Wait. Just redraw it. This will be connected to this. I'll make it. Now what I want 2 inputs, A and B. So that's why I'm going to use slide switches like this, A, and for B another slide switch and take like this, A, B. Since I have more space, I'll use this bit spacing, and this will be connected to ground. I'll make it black. This will be connected to VCC. I'll make it red. Similar fashion, this will be connected to ground. I'll make it black, and this will be connected to VCC. I'll make it red. I'll rename this thing. So this is, let us say A, and I'll rename this switch. This is B. So input A and input B. That's it. Next, what I want XOR gate. The IC number for XOR gate, I think all of you remember, 7486, correct? XOR gate. So I'll use XOR gate over here. This pin number 14 is connected, should be connected to VCC. So let's make it red. Pin number 7 is should be connected to ground. So let's make it black. Okay. Now what I want to do, I want to connect A to XOR, B to XOR. So this A will be connected to XOR input A, and B will be connected to XOR input B. Got it? Let's change the color. Okay, let's take it. So green is A, blue is B, and this will give me A XOR B. So let's take it out to observe the result, and let's make it turquoise, and I'll connect a register over here, and let's make it 1 kilo ohm. Keep it 1 kilo ohm, not an issue. Another LED. Okay, like this. Anode is connected to resistor, and cathode should go to this ground. So that's a black. So this will give me A XOR B. A XOR B, that is difference. Now I want, first of all, I need to take NOT of A. So NOT IC I need to put. So 7404 is the NOT IC, right? X inverter. That I'll post it over here. Now pin number 14 is VCC, so that I'm going to connect over here. Red. pin number 7, that is ground, which I will connect to ground. I'll make it black. Now I want to take a bar, so this is A, right, green. So I am going to connect this to number 1 of this NOT gate, and output will be A bar. So I'll take it out, and that will give, this is nothing but your A bar. So I will make it some another color, purple. So purple is A bar. All of you getting this? I hope it is clear. Now what I want, so I have created A bar. Now next thing is this AND gate we have to connect. So if you remember the IC number, I think it is 7408. So we can take this IC 7408, and then again pin number 14 is VCC, so that will connect. Let's make it red. Pin number 7 is ground, so let's connect this. Let's make it black. Okay, now this is one of the input to AND gate, so we'll connect this. Connect this to one of the input AND gate, and another input is B directly. So this B, blue one, should be connected to this. So either you can connect from here, not an issue, or you can connect from here also, not an issue. So I'll connect it from here. Okay, or if you want, you can connect it from here, not an issue. Both way is okay. So I can connect to here. Let's make it. It is the color for blue. Okay, blue is the color for B. So A is connected to input A, input B, right? Now this is the output, which is nothing but your borrow. So I can connect it at the outside, and let me make it brown, and I'm going to need resistor in order to see it on LED. So I'll make it I'll keep it 1 kilo. Then I'll take a LED. Anode of LED is connected to resistor. Cathode will be connected to ground. Let me make it black. Okay. So this is different. This is what our borrow. Now let's check out this. So before checking out, what I will do, I'll zoom it so that it will be visible. I'll take a print screen of this, so that just for reference. So this is the circuit which we connected. Now what we want to do, we want to make it A equals to B equals to 0. First combination. This is that first combination. A equals to B equals to 0. Let's check out whether the difference and power will be 0, 0. Now start simulation. And if you observe, now A is 0, B is 0. So A difference and borrow are 0, 0. Let's take a screenshot of this and let me paste it here. Now next combination is A equals to 0 and B equals to 1. Let's check out this. A equals to 0 and B equals to 1. Difference should be 1, borrow should be 1. So A equals to 0, B equals to 1. You can check out, both are 1. It means the connection is correct. So let's take a print of this, and I will post it over here. Now third combination is A equals to 1 and B equals to 0. This is the third combination. A equals to 1, B equals to 0. Let's check out what happens. A equals to 1 and B equals to 0. If you observe, difference is 1, borrow is 0. So it means it is correct. And the last combination, which is A equals to B equals to 1, right? And that should give us output 0, 0. So A equals to 1, B equals to 1, and 0, 0. Means whatever we implemented using logic gate is true. I think all of you understood this. Okay. So hence we have proved this truth table also. Now the next part of this is, the third part is, we need to implement it using multiplexer. Now how to implement it using multiplexer? So we can implement it like this. Okay. If you observe how this circuit is, so what I can do, I can show it in parallel. Okay, so if you observe what you are getting, this is a what? This is a mux. Okay, how many pins? Okay, this is a mux. So if you observe this as, okay, I'll implement it and then I'll show you how to do it. So let's go to the Tinkercad once again. And now what I'll do, I'll stop simulation. I'll create another circuit. Even though the connection looks complicated, it is not that complicated. So what I'm going to do, I'm creating a new circuit. Let it load. Okay, now it is loaded. So I'm going to create a new circuit. Basically what I need a 74153 IC. I need a two resistors, two LEDs, and this connection. Okay, this basically ground, VCC, and two inputs. So that we can implement using breadboard. So we use breadboard. We can use small breadboard, not an issue, because this circuit is not going to be so big. Then we will use power supply. So I'll search for power. I'm going to take this power supply and connect this VCC to VCC, and then red, connect this negative to this negative to this pin. This is black. Okay, similarly we can connect this to this and these two. This, change the color. This is black, this is red. Issue. Next 74153 IC I am going to need, so I'll search for 74153. Or first of all I need input A and B, so I'll take a slide switch and connect it over here. This is A. Similarly we'll take another switch which will connect over here. Let us say this is okay. So this as usual will connect to ground. I'm following the same process, okay, every time. This I'm connecting to VCC. So making it red again. Is this visible? I hope it is visible. This is connected to ground. Make it black, and this last terminal I connect to VCC. Red. Okay. So now this is A, this is B. Next part is I want 74153. So I'll search for that. 74153. So this IC is not there. This IC is not there. So let's check out. This IC is 74153. What is that IC number? Give me a minute. What we can do, we can go into this. Let's check out in this. 74153 is 4:1 mix. Okay, dual 4:1 mix. Now let's see what is the another IC number for 4:1 mix and whether it is available or not. So we'll check it on next. So what you can say, dual 4:1 mix IC. And the IC number is 74153. Is there any 74352? Let's check out in Tinkercad whether it is available or not. 7435. It's not there. So means this is not there. Okay. This IC is not there, 74153 is not there. So with the help of Tinkercad, I don't think we can implement it. Okay, so we'll not be able to implement it. So leave it. We have already performed a lot. So what you can do, leave this part, half adder and half subtractor using mux. What you can do, you can put resources used over here from the Tinkercad. I'll show you the. Let me. Okay, I'll show you the resources used which we have used. You can summarize it. So let me delete this because we are not going to need it. Okay, so let's go to the half adder first, and okay, take out the. I'll take a print screen of this. Another print screen I'm going to take, that is for half subtractor. Okay, so as soon as I take it, I'll post it over here. What you have to do, you don't have to write two times. So like for example, power supply is used two times, but it is one quantity only. So you have to write only one time. Slide switch 2. So both are for A and B. Here also slide switch 2. So only you have to write only one time. XOR, even though it is used over here as well as over here, it is one time. 1 kilo ohm resistor is two quantity. So you have to write down only two quantity. Okay, even though 1 kilo ohm one is there, but here we have used two times, two quantities. Okay, so like this, even though it is separate, you have to merge it and you have to find out the optimum resources used. And after that, here we have seen the status just now, so you can mention this over here, and the status is what we have just now seen, which is nothing but what is that? For half adder it is 0 0, and half subtractor it is 0 0. For half adder it is 1 0, then difference is 1, borrow is 1, here it is 1 0, it is difference is 1, borrow is 0, here it is 0 1, here it is difference is 0 0. So this, like this you can mention, and you can draw these circuit diagrams whatever I have shown you. Okay, whatever circuit diagrams I have shown you, this you have to take a printout and you have to mention, or you can draw it on the paper, and you have to write down the question answers which are shown over here. Got it? This question answers you are need to find out. So that's it from experiment number 6 point of view. In the next lecture, when is practical, we will see the experiment number 7. Thank you all.